Hi everyone, my name is Swapna Chimanchodkar, and the topic that I'm going to present today is from farm to fork, end-to-end digital traceability in the food ecosystem. Now, as most of us must be aware, the global food industry operates within a highly interconnected ecosystem involving farmers, processors, distributors, retailers, and consumers. Approximately 33% of food production is lost or wasted due to inefficiencies in supply chain. Consumers, as rightly they should, are increasingly demanding food safety, ethical sourcing, and transparency, prompting companies to adopt digital traceability systems. Now, what's digital traceability? It involves collecting, monitoring, and analyzing data across all stages of supply chain. By leveraging IoT, blockchain, AI, and cloud computing, stakeholders can now do that by they at least have the option to do it, and they can trace products in real time from literally the farm to the fork, mitigating risks of contamination, fraud, and inefficiencies. Now, is it easy to implement this? Of course not. It has its own challenges. Some which is driven by fragmentation across producers, suppliers, and regulators, often preventing true end to end transparency. And this is a major thing, right? And then what that means is challenges would include inconsistent data formats, legacy system integration, and limited adoption of smaller stakeholders. This presentation addresses these gaps and proposes a practical framework for implementation, governance, and adoption, highlighting how digital and process transformation converge to enable full transparency across food ecosystems. Now, we have kind of briefly touched upon some of the challenges in the previous slide. This is a deep dive into that. We said fragmented ecosystems is a challenge because the supply chain involves multiple stakeholders, intermediaries, and regional regulators. As you can imagine, they use different systems and formats most of the times. There are legacy systems and proprietary platforms that prevent seamless data sharing. There is a lack of common standards across borders or even these stakeholders that lead to data misalignment and verification challenges even when they are based locally or within the same border. There is a limited adoption, mainly driven by costs because there is a high initial cost. Implementation of things like IoT, blockchain, and AI require significant capital investments. This challenge just increases when it comes to, say, smaller producers as they face financial and technical barriers. And this ultimately prevents full participation in digital traceability networks. There is also cybersecurity risks, which is increased connectivity that exposes sensitive supply chain data and that could lead to potential breaches. There are governance gaps and compliance gaps. Absence of clear accountability framework undermines trust in traceability claims. Global operations must comply with multiple standards. You have FDA, EU, FIC, ISO, and so on and so forth. So Now, what we looked at in the first couple of slides was the amount of wastage that is created for something so critical and essential. 30% of the produce gets wasted, is what we understood. And then we understood some of the challenges in terms of implementing the technology and also having the traceability or the digital traceability. Now we are going to look at some of the transformation technologies that can actually enable in the food traceability and help overcome some of the issues that we have discussed so far. The first one that we have here is Internet of Things. Internet of Things sensors and RFID devices capture environmental and operational data. Things like temperature, humidity, and location throughout the supply chain. Real-time monitoring reduces spoilage, ensures cold chain integrity, and feeds AI-driven predictive analysis or analytics basically. Blockchain, that's the other digital transformation technology. Blockchain creates a tamper-proof record of product movement, enabling stakeholders to validate authenticity and traceability instantly. Per IBM Food Trust, Walmart leafy greens and meat tracking demonstrate that blockchain can reduce traceability time from days to seconds, improving recall, responses, and compliance. Now, the third thing that we have is artificial intelligence and analytics. We spoke about Internet of Things, how that helps in real-time monitoring. We spoke about blockchain and we looked at how it can reduce the traceability time from days to seconds. Now, artificial intelligence and analytics. AI proposes large-scale data and it can easily process it to predict risks, detect anomalies, and optimize logistics. Machine learning models are also capable of identifying inefficiencies and recommend corrective actions. From fragmented producer network, AI enables consolidation of heterogeneous data, bridging gaps in visibility across small farms and suppliers. So now if you're not able to do like a consistent data across, say, a few areas, it is going to be able to use its intelligence and convert the data in a way in which you are still able to consolidate and you are able to get a visibility across the supply chain. Cloud computing and data integration. So, like in any industry, cloud platforms helps centralize data, which makes it accessible to all the stakeholders in real time. Cloud infrastructure supports interoperable data models and enable analytics at scale, ensuring small producers can participate without costly local infrastructure. So they can just use the cloud infrastructure versus having to do something right from the scratch. And then shared standards. Globally recognized data models like GSI, ISO enable interoperability and verification. So far, the challenge, wasting a lot of food because of inefficiencies in the supply chain. Some of the challenges in terms of trying to implement technology, and then the different digital transformation options or solutions that could help overcome some of these challenges or most of these challenges. While it sounds great, it is important that there is a structured approach in implementation of this digital tools or having a digital transformation along with process transformation. So the steps as laid out here, you can see it starts with assessment and mapping, wherein you actually want to know who your actors are, what are your processes, what are the data touch point across the supply chain. You also want to identify critical control data points for safety, quality, and compliance. As with any transformation project, you would start with assessments, you would start with analysis, you would look at different options, and then you get into implementation. So assessment and mapping is the starting point, and then technology selection, wherein you would look at, say, things like implementing IoT sensor for real-time monitoring, deploying blockchain for immutable record keeping, and integrate AI-based analytics to predict risks and optimize logistics. Data governance and interoperability. Establish standardized data formats and protocols for all participants where possible, and develop access and permission frameworks to balance transparency with confidentiality. All this, of course, is should be human centered, and there should be a human centered adoption. So it's important to train stakeholders, particularly the small stakeholders and producers, to input accurate data and interpret insights that will help the overall supply chain. Offer user friendly dashboards and mobile apps for continuous engagement so that they can see, they can feel part of the overall ecosystem, and they also are able to contribute. You always start with pilot testing and then you scale. So, similarly, in this area as well, conduct small scale pilots to validate system performances, identify bottlenecks, and refine algorithms. Scale iteratively, incorporating feedback that you get from producers, distributors, and regulators. Once we implement, it's always about continuously monitoring, taking feedback, and improving. So use AI and IoT to monitor key performance indicators like traceability coverage, response time, recall response time, food waste, and compliance adherence. Implement a feedback loop to continuously improve system performance and adoption, because you want to be the latest, you want to make things better than you were before, and you want to also add value, and you want to be in line with the market. So you have to continuously monitor, take the feedback, and you need to adopt it. So these are the implementation steps. Now, once you have decided to implement, you went through all these steps, and now coming to practical governance and design mechanics to ensure scalability and reliability. Interoperable data models. So adopt GSI, ISO, codex, and sector-specific standards to ensure consistent representation of product, batch, origin, certification, and process data across the value chain. Interoperability enables seamless data exchange between farmers, processors, logistics, providers, regulators, and retailers, reducing fragmentation and enabling end-to-end traceability at scale. Standardized data structures are especially critical for integrating small producers into large digital ecosystem without costly system overhauls. Accounting frameworks establish clearly defined roles, responsibility, data ownership policies, and auditable digital trails for every participant in the supply chain. Implement governance mechanism, example, things like validation protocol, digital signatures, to reinforce data integrity. Strong accountability structure, build international standards, support regulatory audits, and reduce fraud risk in multi-actor food ecosystem. Again, we spoke about human-centered adoption strategies. So this is a little bit of deep dive into that. Design user interface, training programs, and incentive structures tailored to small holders or small producers and decentralization producers. Ensure mobility first access, low bandwidth functionality, multilingual support, and simplified data capture tools. This is how you would get buy-in from people, because you want it to be human centered. You would have people speaking different languages. You would have uh, you would have basically looked at everybody's needs and tailored it accordingly. Adoption strategies should reduce administrative burden while clearly communicating value like market access, price premiums, faster payments. And human centered designs is essential for scaling traceability without excluding vulnerable or resource constrained factors. Regulatory alignment and compliance enablement. Ensure traceability, and some of these you will kind of see repeating or not repeating, but it is more like an enhancement because these are all critical themes that we are talking that are applicable, and it's important that we deep dive a little bit more into it. And hence, regulatory alignment and compliance enablement ensure traceability align with FDA, EU, FIC, ISO, and relevant national food safety regulation. Embed compliance workflows directly into digital platforms to automate reporting, recall readiness, and documentation. Proactive regulatory alignment reduces legal risk and strengthens credibility with global buyers. Cybersecurity and data privacy, we looked on that very briefly because protecting sensitive commercial and personal data through encryption, access control, rules-based permission, and secure data sharing is very critical, and balance transparency for regulators and consumers with confidentiality for the producers. There needs to be balance. Strong cybersecurity safeguards are foundational to maintaining trust and encouraging participation across the ecosystem. Ecosystem integration and scalability mechanisms, enabling modular system architecture, API based integration, cloud infrastructure to support growth across regions and supplier tiers, ensuring solutions are cost effective, scalable design to ensure traceable systems can expand from pilot to something bigger, which could be national, global, whatever is the next stage of growth. Trust and transparency enablement provide accessible traceability insights to consumers, regulators, and buyers. Things like QR code, certification variation, and origin transparency and transparency systems strengthens brand trust, reduce information asymmetry, and reward compliant producers, especially small holders seeking differentiation in competitive markets. Now, let's look at where all does the transformation need to happen in food ecosystem. So when we're talking of the end-to-end ecosystem, it would drive process transformation at multiple levels, at farm level, at processing level, at distribution and retail level, and consumer level. Farm level, digital sensor monitors soil, crop health, and livestock, optimizing yield and reducing resource usage. Processing level, automated quality checks, IoT enablement tracking, and blockchain authentication, enhancing efficiency and compliance. AI-driven logistics optimize routing, reduce delays, and maintain cold chain integrity. And consumer level, which is basically QR code and apps that can help provide transparency, etc., are all introduced into the process. And that's just basically process reengineering, as in you had a process and then you're reengineering it. So now some interesting points, or basically a data point which substantiates the importance of this. As per Capgemini research, organizations adopting digital traceability wrote about 15 to 25% reduction in operational losses and a 20% faster response time in recalls. That's a lot of profit and lesser food wastage. We spoke about KPIs. Now, how do we, get track KPIs, and what are the key metrics which could tell us whether we are being successful, or how do we know that we are being going in the right direction? So some of the key indicators that could help us enable us with that would be supply chain transparency, that is number of products traceable end to end, recall response time, reduction in time to identify and remove unsafe products, that could do a lot of damage to your trust if it's not done in time. Food waste reduction, quantitative reduction in spoilage and unsold items, compliance adherence, alignment with regulatory and sustainability standards, customer trust surveys, product authentication feedback, and brand reputation metrics. Now, we looked at the metrics, and let's look at some of the actual values or additional actual values, which kind of talk to the business impact of implementing end-to-end digital traceability. The implementation delivers, as we know, economic, operational, and risk mitigation benefits across the system. Now, when we are looking at technology, let's look at some of the operational efficiencies and cost reduction that it may bring. 10 to 30% reduction in food waste through real-time monitoring of spoilage, cold chain breaches, and inventory aging, driven by IoT and predictive analytics, which are some of the tools that we looked at already in the previous slides. 15 to 25% improvement in supply chain efficiencies, and about 20 to 40% reduction in recall related costs. That's the operational efficiency and cost reduction, recall response and risk mitigation. If you see, digital traceability systems reduce product traceback time for days or weeks to seconds and minutes, lowering financial exposure, regulatory penalties, and brand damage. Now, 30 to 50% lower compliance and audit costs is what we are looking at, which is pretty high. Revenue protection and brand value, enhanced transparency and provenance verification that contributes to 2 to 7% revenue uplift for brands leveraging traceability as a consumer trust, and sustainability differentiator, reduced fraud and counterfeit, which is spoke about as a possible issue, can protect 1 to 3% of annual revenue, especially in high value categories like organic, specialty, and export oriented foods. Because if there is fraud, if there is counterfeiting, and the brand damage that comes from it, it's extremely high in these areas. Investment perspective. While initial implementation costs can vary by scale and complexities, but it can still be high. I mean, comparatively, maybe for a smaller producer, a smaller money could be high cost too, but just keep leaving that aside for a second, which is very critical, but we'll just leave it aside for a second. Organizations typically report return on investments within 18 to 36 months. So say even somebody is able to invest that money, even if it's tough, within 18 months to 36 months, you get your money back. And after that, it's just better than where you were before. It leads to so much value add. So, and particularly where traceability initiatives are integrated with broader digital transformation program, because it is critical in this particular case to have that traceability. And if we look at the summary impact snapshot on the right, we have gone through so far is summarized here. So with adoption of implementing the end-to-end digital traceability, um, there is a waste reduction of 10 to 30%, recall cost reduction of 20 to 40%, supply chain efficiency gains 15 to 25%, and compliance cost reduction 30 to 50%, and revenue uplift 2 to 7%. This is based on various sources, and you see it's extremely impactful. Now, we started with a problem statement, 30% wastage, some of the challenges even in implementing the technology, some of the technology options that we had, the different stages and steps. We looked at some of the governance frameworks, and then we also looked at the metrics and the dollar impact that brings in. And now we move on to the future outlook. As you can imagine, we are seeing a lot of value, and somebody who is not going to adopt digital solutions may be left behind over a period of time. And the future of end-to-end digital traceability will be shaped by technology convergence, regulatory evolution, and ecosystem-wide collaboration. As food systems grow more complex and sustainable, expectations intensifies, and then you will need tracking mechanisms that with predictive and intelligent-driven capabilities. Now, technology trajectory. We're going to look at a few themes in terms of the future outlook as well. The first one is technology trajectory. AI first traceability, advanced machine learning models will move beyond monitoring to predict contamination risks, demand fluctuations, and supply eruptions, enabling proactive intervention. Digital twins of food supply chain, virtual replica of supply chain will simulate scenarios such as climate impact, transportation disruption, and policy changes, improving resilience and planning. Wouldn't it be wonderful that you could have a digital twin instead of you going through the experience, it goes through it and tells you. Edge computing and real-time intelligence processing data closer to the source will enable faster decision making in remote farms and processing facilities. Interoperable blockchain ecosystems, a shift from blockchain pilots to federated interoperable networks will support cross-border and multi-stakeholder traceability. Regulatory and market developments, governments and regulators are expected to mandate or will be expected basically in many cases for high food categories, increasing adoption across global markets. Sustainability reporting requirements will become tighter with traceability like ESG metrics, carbon accounting, and export markets will increasingly require digital verifiable provenance and compliance evidence, making traceability a competitive necessity. Inclusion of small producers, low cost mobile platforms, cloud based solutions, and shared infrastructure models will enable small and fragmented producers to participate without prohibitive investment. Cooperative data sharing models and public private partnerships will reduce adoption barriers and promote equitable value distribution. Strategic implications. In the long term, organizations will treat traceability as a core digital capability rather than compliance tool, and they will gain advantages in supply chain resilience, regulatory readiness, sustainability leadership, and consumer trust and brand differentiation. We have seen most of these before in the previous slides. Now, some of the key conclusions. End-to-end digital traceability in global food industry is primarily a process and governance challenge rather than purely technological one. It is technological one, but it's not just in silos. So you're looking at process, you're looking at governance also. So it's basically both process and digital transformation. Fragmentation across producers, suppliers, and regulators continues to limit transparency despite the availability of advanced digital tools. Successful traceability, therefore, requires ecosystem-wide process alignment, interoperable data standards, and shared accountability mechanisms. When combined with AI-driven analytics and real-time integration, digital traceability delivers measurable business value, including reduction in food waste and recall cost, improved regulatory compliance, and enhanced brand trust. These benefits position traceability as a strategic capability rather than compliance obligation. Looking ahead, the evolution towards predictive, intelligent traceability system will enable proactive risk management and sustainability optimization. Organizations that adopt inclusive human-centered implementation models, particularly those supporting small producers, will be best positioned to scale traceability and strengthen resilience across food ecosystems. The key takeaways from the presentation: end-to-end traceability, and this is a repeat of what we see, but again a critical thing, because as we end, some of the things that we can definitely take away is end-to-end traceability is a system level transformation, not an isolated digital initiative. So it has to be a partnership of both process and digital transformation. Digital, lot of value, but without process, it's not going to completely work. Quantified economic benefits reinforce the business case for traceability investments. AI and real-time data are essential for scalable and predictive traceability. Interoperable standards and governance are critical to trust and compliance. The future of food traceability lies in intelligent ecosystem-driven platforms. With that, I end the presentation. Again, my name is Swapna Chimanchodkar, and I'm glad to be part of the AI in new era. If any questions, please do let me know. Thanks.